Good afternoon, everyone. I am Dr. Deepa Philip. I am a professor in Industrial Management Engineering from IIT Kanpur, and this course is titled Artificial Intelligence in Industrial Management Engineering, which is offered as part of the MOOCs course or the MOOCs course basket from IIT Kanpur. And along with me, this course is co-taught by Dr. Prabal Pratap Singh. And today we are in the week 4, and today's topic that we are going to talk about is searching and sorting. Sorting is a little bit we will cover, but searching is majorly what we are going to get into, and how searching is very important tool in the AI domain. So without any further delay, if you look at the topic, it is called sorting and searching, and this discussion today is more related to how it is important for the AI domain. So let's start with the first topic, which is relevance of sorting and searching. Okay, how relevant it is. Okay, so the first thing is both sorting and searching, both of these. Okay, they are fundamental problems. Fundamental problems in CS and programming. Okay. And what is CS? CS stands for computer science. Okay. So, there are fundamental problems in computer science and programming. Okay. So, the search, when we talk about search, is a class of techniques. So, in broad terms, it is a class of techniques for systematically finding or constructing solutions to problems. So, the key thing here is it is a class of techniques. Search is a class of techniques whose aim is to either systematically find or construct solutions to problem. You are either looking for systematic finding or search, or systematic construction of solution to a problem. So, examples or an example technique. Okay. And let us name this as generate and test. So, how will we do this? The first thing is generate and test, and let us say example problem. Okay, what we call as number lock or the combination lock. So, these are the locks in which you have dials with numbers in it, and you can use these numbers to different combination of the numbers will open the lock for you. Okay. So, the step here in this, create or generate a possible solution. You generate a possible solution which is a combination of the numbers with the various dials. Test the solution. When you put this and pull the lock to see whether the solution is working. Okay. If solution found, if you find the solution, then done. Okay. Else return to step 1. Go here, generate new solution, try to repeat the same problem. Okay. So, this is how you find which is the number lock combination for a given number lock. So, now why do you sort? We talked about what is search, then why do you need to sort, or what is the importance of the sort? Okay. The answer to this is it is done to make searching easier. You want to make searching easier. Okay. So, the sorting is done to make searching easier. Also, multiple algorithms are available, many algorithms are available to solve the same problem of both sort and search. Okay. There are many algorithms that are available, multiple algorithms are available. Okay. Question is, how do you know which algorithm is better? How do you determine which algorithm is better? That is the other part of the problem, is better. You have multiple algorithms to solve the same problem, but you need to find out which one of them is better. Okay. So, this is the second aspect in this class. So, in the AI or artificial intelligence, the search, okay, is an important aspect. Why is it important? Okay. Why is it important? Okay. The reason being is many AI problems can be formulated as search problems. Okay. We can formulate the AI problems as search problems. Now, examples. Okay. What are some of the examples? Path planning, okay, or routing, okay, games, natural language processing, NLP, okay, then machine learning, genetic algorithms. Okay. These are some important examples, and these problems are very critical in the AI domain, and people, there is a lot of work going on both in industry and academia in this region. So, hence that is why search is important. Now, let us discuss briefly about sorting. A fundamental application for computers. So, we said it is very common and it is very important, and we told that it is done to make searching easier, or it is done to make finding data easier. Okay. You want to find data quickly, and finding data is also known as searching. Okay. So, it is done to make searching easier. Then as we said, many sort algorithms exist. There are many of them that exist. Then, since there are many exist, the critical aspect that we need to do is major difficulty of sorting. What is the major difficulty of sorting? Working with a fixed size, you are working with a fixed size storage container. Okay. You are working with a fixed size storage container, most popularly known as array. Okay. A storage container is array. Okay. If you resize the array, okay, it is expensive. Okay. This is also known as slow or computationally expensive, which means the time will taken is very slow. If you resize the array, okay, if you change the size of the array. Now, many of the simple sorts, many of the simple, what you call as a simple sort algorithms run in quadratic time. Quadratic time means order of n square. Okay. So, as the number of items to be sorted increases, the time increases quadratically. Some examples of it is bubble sort, selection sort, these are the simple sorts, selection sort, insertion sort, they all run in quadratic time period. Okay. So, this is about sorting. Now, we go back to the searching again, and in searching we can say given a list of data, you are given with a list of data, find the location of a particular value. You are finding the location of a particular value, or if it is not there, or report that the value is not present. Okay. So, the critical thing is either you find the location of the particular value. So, you are given a list of data is given to you, you find the location of a particular value, or you report that the value is not present, it is not in the list. Okay. So, one way to think about it is, let us think about something called linear search. Okay. It is simple way to think about it. It is number one, it is an intuitive approach. Okay. It is very intuitive to human beings because we are trained to think linearly. So, this is an intuitive approach. Use this bullet. Within this, start at the first item. You are starting at the first item. Then, is this the one you are looking for? Okay. If not, go to the next item. Repeat until item is found or all items are checked. Okay. So, this is the simple way of thinking it, where you will actually start with the first item. You start with the initial item, then you check, is this what you are looking for? Is this the item you are looking for? The answer is yes, then you are done. Okay. If yes, you are done. Okay. You can stop. If it is not, then what do? You go to the next item. Okay. And when will you stop? You stop until the item is found. You find the item, you stop, or you completed with all items. If this is the case, this means the item is not present in the list. So, here you will understand that the item is then not present in the list, if you check through all the items and then nothing is found. Okay. Now, if items are not sorted or unsortable, you can't sort the item or is unsortable, then this approach is necessary. If you cannot arrange these items that you have, or it is not sorted, then this approach is usually makes sense. Okay. Now, how do you search, or how do you search in a sorted list? So, if you see, we are saying that given a list of data, this is starting point, right. So, how do you, that list is given to you in sorted. So, the first thing is, if items are sorted or list is sorted, the list of the items are sorted, either case the items are sorted or list of is sorted, then we can do what we call as divide and conquer. Okay. So, we can divide and conquer. So, how do you divide and conquer? Okay. How? Question is how? Dividing your work in half with each step. Okay. With each and every step, at every step you are dividing your work in half. Okay. Generally a good thing. Okay. It is usually a good thing. So, such kind of a thing is sometimes known as the binary search on list in ascending order, sorted in increasing order, right. So, if how do you do this? You do this by start at the middle of the list. Okay. You are starting at the middle. In the earlier case you started with the first item, but since it's sorted, so you are starting at the middle of the list. Okay. So, the trick we are going to do here is divide and conquer. Okay. And each step you are going to divide it into half. Okay. So, you start at the middle of the list. Then the second thing is that the item? That is the next question. Okay. If not, the next thing we do is it greater than or less than the item. Okay. So, if this is the item, if you take the middle of the list, if that is the item, if yes, then stop, you found the item. Okay. If it is not, then what you do is it, which is this it is the middle item. Okay. The middle item, is it greater than or less than the item? Less than the item, which is this item, this is what you are looking for. Okay. Looking for. If less than, move to the upper half of the list. If greater than, move to the lower half of the list. So, the middle item that you picked, if it is less than, if it is greater than the selected item, then you will find it below. Okay. Then repeat until found or sublist size equal to 0. Okay. There is, which means no more item in the sublist. Okay. If there is no more item in the sublist or sublist size is equal to 0, then you stop. Okay. So, if I want to do this in a graphical way, or if I want to demonstrate it to you, let us assume that this is your list. Okay. list and it contains, okay, this is the low item, this is the high item. Okay. This list is sorted ascending. So, this means it is ordered in the ascending fashion, right, and somewhere here we call this is the middle item. Okay. So, the first question, as I said earlier, is that is middle item what we are looking for? The first question is this. Okay. So, that means, okay, is the middle item is equal to what you are looking for. Okay. So, then if not, is it means it is the middle item, is it more or less than the targeted item? Okay. Targeted item is what you are looking for. Okay. So, you take the middle item, if it is this what you are looking for? If it is not, okay, then we say is it more or less. Okay. Now, we will say let us assume that the targeted item what you are looking for is lesser than the middle item. Okay. So, if the targeted item is lesser than the middle item, where will you find it? Then where will you find it? Okay. You will find it in, if you take this same list, okay, this is your low, this is your high, and this is your middle. Since the middle item is lower, you will find it here. Okay. So, this is where it should be. Okay. You will find it here. So, if that is the case, then what will you do? You take this portion and you have just this. Okay. So, this is your low, this middle will become your high, and you now find a new middle. Okay. So, this is the same. So, you now only focus on this side. So, you do not ignore this. Okay. So, your work keeps on dividing by half in this binary search. Okay. So, let us do one example, a small example as part of this, and then go from there. So, example. Okay. So, let us do this. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Sorry. Okay. So, it's 15, let us do 16. Okay. So, it says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, these are the indexes of the list. Okay. I am putting the values here. Let me put the values as 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53. Okay. Let us like this, some values are there. So, let us say if your target is to find whether there is 7, okay. Say if target is 7, what will you do? In the list, this is your low item, this is your high, okay. And so, since there is 16, so what will you do? 1, 2, 3, 4, 5, 6, 7, 8. So, this will be your middle item, right. Okay. So, you check is 19 less than 7. Okay. So, your middle item, is it middle less than the intended target? So, you find that 7 will actually fall here. Target item will be here. Okay. Then you keep on doing, okay, and then you find it. So, the example implementation in C. Okay. How do you implement this in C? Okay. So, let us think about it as public, just a pseudocode, we are static int, okay. Let us call it as B search. It is int, it is an array called a list, comma int target. You are sending the target to it. Then you can say int result, which is equal to -1. Okay. Then int low equals 0. I am just saving space. Int high equal to list length, list dot length -1. Okay. So, high is the list length -1, because the index starts from 0, that is why. Okay. Index starts at 0. Okay. Now, int mid, okay. Then you will say while bracket result equal to -1, okay, and low less than or equal to high. Okay. If result is -1, that means you have not found the result and it is high, and low is less than or equal to high, that means that is still the list is not empty. Okay. Mid is equal to low plus bracket of high minus low divided by 2, okay, semicolon. So, you find the mid. Okay. If list mid, okay, is equal to target. If so, if you find the middle of the list is equal to the target, right, then result equal to mid. Okay, you found the result. Else, if, okay, list mid, the middle item is less than target, the middle of the item is less than the target, then we say low equal to mid plus 1, else high equal to mid minus 1. Okay. Then we call it as you close this here, then the rest of the code is return result, okay, and that is it. So, this is a simple C code of, so you keep on dividing until you find the item. So, this is a simple implementation of the whole thing in C code, but you may be using Python or any other language. So, you can, and there is much better code available on this. So, I am just showing you as an example. So, with this stuff we will stop here and we will start discussing about the other search algorithms from the next class. Thank you.